Scientists warned that the volcano that caused the largest eruption in European history might be getting ready to blow again.
Seismic monitors across the Naples metropolitan area recorded 22 earthquakes in a single week. The strongest barely registered 1.7 on the magnitude scale. To the untrained eye, the numbers seem almost trivial. But the scientists watching the data understand something the numbers alone cannot convey. Beneath the streets of Pozzuoli, beneath the ancient Roman ruins slowly sinking into the harbor, beneath the homes of 3 million people, something vast is stirring. And it has not stopped stirring for years. The bulletin issued February 10, 2026, contains 3 numbers that matter. 22 earthquakes. Ground uplift averaging 15 millimeters per month. Fumarole temperatures at Boca Grande reaching 173 degrees Celsius. And then the bulletin contains one sentence that sounds almost reassuring. There are no elements suggesting significant short-term evolution. But if the official line says nothing has changed, why does the system still demand attention? Why do volcanologists around the world still watch every weekly update from this caldera with careful, unblinking focus? The answer lies in understanding what Campi Flegrei actually is, and why scientists treat it with such constant, meticulous vigilance. West of Naples, centered around the coastal city of Pozzuoli, lies one of the most dangerous volcanic systems on Earth. Campi Flegrei is not a mountain. It is a caldera, a vast collapse structure roughly 12 to 15 kilometers across, formed by catastrophic eruptions that occurred tens of thousands of years ago. The Campanian Ignimbrite eruption, 39,000 years ago, ejected hundreds of cubic kilometers of volcanic material into the atmosphere and left ash deposits across Eastern Europe. 15,000 years later, another massive eruption carved out more of the caldera. The entire Naples metropolitan area sits inside this ancient wound in the Earth's crust. Beneath it, a complex system of magma chambers and hydrothermal reservoirs continues to breathe, to heat, to rise. The caldera is not dormant. It is restless. And it has been growing more restless for decades. The weekly bulletin from INGV is not a prediction document. It makes no claims about when or whether an eruption will occur. Instead, it functions as a status report, a structured snapshot of 3 pillars that volcanologists use to track what the system is doing: seismology, deformation, geochemistry. Each tells part of the story, none tells the whole truth. And none can promise certainty about what comes next. 22 earthquakes sounds like a headline. But at Campi Flegrei, small earthquakes are common during periods of unrest. They represent rock cracking under pressure, fluids forcing their way through ancient fractures, the caldera adjusting to forces pushing up from below. The earthquakes this week clustered at shallow depths, just a couple of kilometers beneath the surface, in the zone where hydrothermal fluids and heated rock interact. The pattern matters more than any single number. Depth matters. Location matters. Whether the quakes cluster or scatter matters. You can have an entirely uneventful week that still fits into a longer escalation trend. The bulletin lists the specific events, catalogues their magnitudes and locations, but the interpretation requires context that only emerges over months and years of accumulated data. 1 week of quiet means nothing. 1 week of activity means nothing. The trend is everything. The ground is still rising. This is the phenomenon the Italians call bradyseism, the slow breath of a restless caldera. At the Wright monitoring station, scientists have recorded approximately 24 centimeters of cumulative uplift since January 2025 alone. The ancient Roman marketplace at Pozzuoli, the Macellum, bears the scars of this motion in the form of boreholes left by marine mollusks on its columns, evidence that the ground has risen and fallen by meters over the centuries. But the story this week is about rate, not just total movement. Since mid-December, the uplift rate has decreased to approximately 15 millimeters per month, plus or minus 3. This might sound like good news. It is not necessarily good news. The system has fluctuated before. After a swarm of earthquakes in mid-February 2025, the uplift rate jumped to roughly 30 millimeters per month. By early April, it had dropped back to 15. Then, in October, it climbed again to 25. Now it has slowed once more. A lower rate does not mean the problem is solved. It can mean the system is adjusting, that pressure is redistributing, that the hydrothermal system is finding new pathways to release heat and gas. The caldera does not move in straight lines toward eruption. It fluctuates, it stalls, it accelerates, it pauses. This is precisely what makes prediction so profoundly difficult. Geochemistry is the slow alarm. It does not make headlines the way earthquakes do. But in many volcanic systems, changes in gas composition and temperature have preceded visible activity by months or even years. The bulletin confirms that the long-term trend of hydrothermal heating and increased fluid flux remains intact. This is not a system cooling down. At Pisciarelli, the fumarole temperature averages approximately 95 degrees Celsius, hovering near what scientists call condensation conditions, the threshold where steam begins to dominate over dry gas. When you hear steam hissing from vents at Pisciarelli, you are hearing water flash to vapor as superheated fluids rise from depth and hit cooler rock near the surface. At Solfatara, the Bocca Grande fumarole shows an increasing trend, averaging 173 degrees Celsius over the past week. Carbon dioxide flux at Pisciarelli shows no significant variation compared to recent periods. This is the nature of geochemistry. It can lead visible activity by a long margin, but it does not translate into a countdown clock. There is no clean threshold that says when readings reach a certain level, eruption follows in a predictable number of days. The gases rise, the temperatures climb, and the scientists watch. The sentence that closes the bulletin, that there are no elements suggesting significant evolution in the short term, is not a statement of safety. It is a statement of epistemic humility. It means that based on currently monitored signals, scientists see no indication of an imminent step change. It does not mean the system is harmless. It does not mean an eruption is impossible. It means that forecasting volcanic activity involves profound uncertainty, and the monitoring system is designed to catch changes early, not to promise certainty that does not exist. The official message is steady because the job is to be accurate, not dramatic. The scientists are not trying to calm anyone. They are trying to tell the truth. What would count as a meaningful change? Scientists watch for sustained upticks in earthquake rates or magnitudes. They watch for clear acceleration in uplift rate or new deformation patterns that suggest something different is happening at depth. They watch for rapid shifts in gas composition or flux, or temperatures moving outside recent bounds. Most importantly, they watch for multi-parameter agreement, multiple signals moving together in ways that suggest a coherent change in the underlying system. One noisy signal is not a red flag. Several signals converging is. The bulletin notes that any significant variations will be investigated and communicated. That promise is the infrastructure of warning. 3 million people live in the Naples metropolitan area. Many of them have lived their entire lives in the shadow of Vesuvius, in the streets above Campi Flegrei, in a landscape shaped by explosive volcanism over hundreds of thousands of years. This is one of the highest volcanic risk settings on Earth, not because an eruption is imminent, but because when activity does occur, the consequences for a densely populated region are severe. The challenge is fatigue. Normal life continues on top of unrest. Buildings still crack from the rising ground. The harbor at Pozzuoli still shifts. The fumaroles still steam with that sulfurous stench that residents have known for generations. And every week, a bulletin comes out with numbers that mean nothing to most people, and everything to the scientists whose job is to watch for change. The bulletin from February 10, 2026, describes a caldera in ongoing unrest. The numbers are not alarming in isolation. They are alarming in context. 24 centimeters of cumulative uplift. Temperatures climbing at Boca Grande. A long-term trend of hydrothermal pressurization that has not reversed. The official assessment is that nothing indicates a short-term change. But the system is not quiet. It is simply doing what it has been doing for years: rising, heating, venting, waiting. If parameters shift, the bulletin will reflect it. If multiple signals converge, the alert level will change. For now, the task is to watch, to measure, to record. And to understand that boring weekly bulletins matter precisely because they are the infrastructure of warning. The accumulation of data that will allow scientists to recognize when something truly is different. The caldera breathes. The instruments listen. And the world waits to see what comes next. Subscribe for monitoring-based updates. When the numbers change, we will show you exactly which ones changed and why.